All right, for this video, what we're going to be doing is we're going to be exploring what gimbal space is exactly. Like we mentioned in other videos, gimbal space is the true values for Euler. Basically, what you see in your F-curve or graph editor corresponds always with the gimbal space gizmo controller. And always remember, everything that you do always gets translated into a transform matrix in some way or another. So Euler is just one method. Euler rotation is a three-dimensional solution to dealing with rotation. And it comes with a couple of issues because of the fact that it's limited to three values. A quaternion, for example, is a four-dimensional coordinate, and it's much more accurate for rotation. However, it comes with its own issues, especially when you're dealing with animation. We usually use Euler or Euler. Euler is used for, in particular, because it is easy to graph. Like you can show the value over time, whereas in a quaternion with quaternion values, it's really hard to visualize what that even means. You're looking at the values and you don't quite understand what it means. Even though there are ways of visualizing quaternion, but it's really hard to graph. So Euler is really good for visualization. It's also got its quirks as well. You may have heard of gimbal lock. So like we talked about that in the previous video. If you haven't seen that one I strongly suggest watching that. So here, what we're going to do is very basic. It's very basic. What we're going to do is we're going to start with a cube, and I'm going to. You could double click here on the rotation in Maya, for example, and you could go and change things here with which kind of space you want to rotate the object in. But for now, I'm going to be using, because it's easier, Control Shift and right click, and I strongly suggest using this one because you don't want to be going into those kind of like menus. You want to be able to just quickly switch to whichever one you want. So I'm going to start with object because that's kind of the one that everybody likes so much. But truth be told, as you saw in the other video, we know that this is not really the right one, and here I'm gonna prove it to you. So it's not the real one, right? So if I'm gonna undo that. If you look over here in the channel box, you're gonna see that we're gonna be looking at the values that get affected when I rotate something. So if I rotate the X value, seems to be fine. If I rotate the X value, seems to be fine. If I rotate the Y value, seems to be fine. Now, what if I rotate on one of these, then leave it there, and then let's say I go onto the Y. Seems to be fine. On the X, fine. Z, whoa, what's going on here? So basically, as you noticed, at the beginning it's fine because we're starting at 0, but as we move along, we progressively get to the point where whichever one you use, with the exception of maybe the X rotation, will always change the values of all the other three. And that's a bit of a problem, because if you're animating and you're thinking about the values that are in your graph editor, you'll be affecting all of these. So what happens with Euler is that one of the biggest disadvantages of Euler is that the same orientation of an object can actually be represented with two completely different sets of values. That's how inaccurate Euler is. It's got multiple solutions for the exact same orientation in space. So while you're moving this, it's trying to find the best solution. It's going to try to find the best of those two. But eventually you're going to add a key where they're really far apart from each other, and because of gimbal lock, and you're going to end up with a lot of difficulty for it to calculate how to get there, right? So that's again, that's like the other video where we had gimbal lock. Okay, so moving on. Let's bring this back to 0. Actually, I'm just going to type it here, 0. So now if I switch to, we're going to bypass world because it's going to be more of the same. In fact, that one's going to break faster. I'm just going to go to make sure I'm on gimbal. Gimbal, the first thing we're going to do is we're going to rotate on X. And what we're going to notice, hopefully you can see this clearly, is that the gizmo ball is not really, doesn't seem like it's actually even moving. Whereas if I go to, let's say, the Z rotation, when I rotate that one, the other two do move, right? And that's kind of a peculiar thing. That's the first thing we need to notice. However, so what do you think is going to happen when I rotate the y-axis? So if I rotate the y-axis, this is getting weird, right? Because now the x-axis and the z-axis, one's being affected, but the other one is not. And this actually is what we call gimbal lock, because the second that you rotate on the 90 degrees on the y-axis, these two axes are basically now overlapping each other. And if I were to leave it there and I wanted to rotate it on the other axis that I had before, it's like I've lost the ability to rotate in that way. So if I were to switch to like object space or world space, it's going to have a tough time figuring out which values are going to be necessary for this to work. And again, we're going to get to that gimbal issue. But at least in gimbal space, what you're gonna notice is no matter which operation you do, how many things you change, the channels over here on the right will always just modify the one that I'm changing. So this one corresponds with what's in your graph editor, 1-to-1. So if you're animating, try to use gimbal as often as you can. And if you've gotten to the point where gimbal can no longer give you what you need, then of course switch to object, but know that the second that you've reached that point, things are going to get messy for sure. So be very, very careful. And that's where the Euler fix tools and all that stuff come in. But let's keep that. Let's talk about that later. Right now, what we need to focus on here is just we're trying to understand what these Euler values are doing and why this is happening. So the next thing I'm going to do is I'm going to show you something that I have hidden in the scene. I'm going to put all this back to 0. And it goes back to our first video that we made about dependencies. So this is an object, and I've gone ahead and I've created basically 3 different objects, each one with a different color. So for example, here's the x-axis. And it's if you look at the local rotation axis, you're going to see that I've correctly, let me go into wireframe mode and zoom in a lot, because for whatever reason the local rotation axis won't be drawn on top of the mesh. But anyways, not important right now. But if you look carefully, the x is pointing that way, z's that way, and y is that way, and it's correctly aligned with the x-axis here. So all of these objects have been aligned relative to an axis, a specific axis, and which means what I've done here is I've actually parented them in the order of Z, Y, and X. And the reason why I did it that way is because in this little example, when we were rotating the gimbal, we noticed that one was affecting all of them, one was affecting none of them, and another one was affecting one but not the other. Another way of looking at, most people, like I've met people who never even figured this out ever. I never understood this. Like to understand rotation, you got to understand that it's kind of like a mini parenting inside. So X is the leaf node, where it doesn't have any children, so it doesn't affect anything, and Z is the grandparent node, where it affects everything. So when it's calculating internally the rotation, it's kind of like this little mini hierarchy. And here's the proof of it. Okay, all I've done is if I look in my node editor, gone ahead over here, and we don't need this. This is something that I'm going to remove. Okay, so I've gone ahead and I've set this up so that the cube has its rotation XYZ, and it's plugged into each of the individual rotations. So it's driving the rotation that it is labeled after. So in the case of a rotation Z, it's on the object that I call the Z-axis, and it's only on the rotate Z, that's the Z-axis object, and so on. So I've set that up like this. And again, this is like if you think about it, this is from the point of view of dependencies, this object, this transform now has a rotate X that depends on this one. So again, just trying to help you visualize and understand how all these dependencies work. So the important thing here is that I've hooked up the individual values from the rotations onto this setup where each object is a child of the other one based on what we understood from when we were rotating in Gimbal. So what you're going to find is that when you're rotating this object over here in Gimbal space, you're going to have a one-to-one representation of it. Like no matter what you do, it's going to, even gimbal lock, here you can actually clearly see what's happening in gimbal lock. And of course, that's a minus 90-degree rotation on the on a y-axis. So that means because we have an XYZ order, you'll have two axes that are touching. And this is the exact definition of gimbal lock. So we're actually seeing the axis itself overlapping itself, something you don't see with a gimbal ball gizmo. But we have with this. This allows us to better understand. See, like the gimbal shape is exactly the same. So this is just to prove and to better understand and visualize that a rotation, when you're dealing with Euler, is that Euler has this kind of a little mini hierarchy inside of it. And in fact, when you're rotating objects in Maya or any other software, really, internally the software will create these transforms for each one of these rotations and multiply them in the order that gives you this kind of behavior. And then that will become its rotation, and that will be calculated as a transform matrix. So if I go back to my node editor, one of the important things here would be, let's see here, you have XForm matrix, and you have also just matrix. That's the one. See, when internally, it doesn't matter what your inputs are, it will figure out, it will calculate a matrix in the end. And we've just kind of like looked at it a little bit by doing this. So we're starting to see how internally it's setting these things up. So for rotation, keep in mind these little gizmo balls that I've created, and that there's kind of like a mini parenting. So again, same idea, two fundamental concepts in every software: dependencies and transforms. And we're just seeing yet another example of how rotation works.